So, yeah, go quick. So, first of all, I'm really hoping that you tried the worksheet with the one inequality word problems, right? If you didn't, I still strongly encourage you to do that. Did I post the answer key for that one? Yeah. Okay, see, that's how I test you that you did your homework. Yeah. If you're late, then you didn't do it. No, I'm sometimes joke about it, but I'm serious. Do your homework because it pays off. It always does. Ask those that are doing their homework. It pays off. Okay. Um, you won't just. Something is off with this. I'll start writing and then I will focus. Okay. So we did word problems with just one inequality, and now we're going to do two or more. Okay. Word problems involving 2 plus inequalities. Let's save some writing if we can, right? And now we'll try to focus, see if it's better. There. Okay. So we'll jump straight into an example because the steps remain the same. Now that I actually remember something that I wanted to mention. We kind of ran out of time yesterday. There's something I forgot to do. You have this in your notes, right? It's right there. I forgot to mention the corner points, the POIs, right? So if you can, somewhere on the side, next to it or somewhere, and it's not going to take up that much room. The one of the corner points is 0, 0, which seems a little irrelevant, doesn't it? But it is. It is surrounding my solution region because remember, the x and the y axis act as a line when it's a word problem. So 8, 0 and 0, 12. All of them I just read off the graph. So sometimes in my answer key, I'll just say, hey, I just read this one off the graph. And so sometimes when we do a question on a quiz or whatever, if you just have to read it off, it's not going to be worth as much as if you have to use the calculator to go get it. Okay? So none of these, we didn't have any decimals, so we didn't have to round. And today I made sure some of those corner points will be decimals, so you have to round. Okay? So please add that. I apologize, I didn't have that on there, but at least we got. So this will be the fifth step, right? So now we have it all taken care of. Okay, there you go. So now we're gonna start with a problem right away. A bakery has two options for cakes or two. Cake A requires 150 grams of flour, while cake B requires 75 grams. The bakery has 50 kilograms of flour available in order to profit. Profit means, right, you make money instead of losing. The bakery needs needs to produce at least 500 cakes. And I will just do this to walk us through this. Define variables, state implicit constraint, C, write inequalities for each restriction. The graph and E state a possible solution. And then state POIs. So here, if you read it, there's 2 cakes, right? That's probably important. And as you keep reading, it's cake A and cake B, right? So when we want to define our variables, we're just going to let X be number of cakes A. Y is going to be number of cakes B. That's it. B is asking us to state the implicit constraint. That's just saying this. X comma Y, both of them have to be positive. Good, right? And then C is probably the most difficult part. Write the inequalities. Okay. So for C, we're going to write the inequalities. And that requires reading. The first thing I want you to try to find is the restrictions that are placed on you. Okay? So forget about how much is made or whatever. Look for restrictions because that's going to guide you and tell you how many inequalities are present. Okay, so cake A requires 150, well, cake B requires 75. Right there, there's no restriction on that. They're just telling you how much you need for each. But then it says the bakery has 50 kilograms of flour available. So that right there is a restriction. I know that this might make it a little busy, but restriction on flour. Sorry about that, but I'm just writing down restriction on flour, so that's my inequality 1. So I will go like this, IQ number 1. Okay? Let's continue reading. In order to profit, the bakery needs to produce at least 500 cakes. So produce at least 500 cakes. Restriction on number of cakes, and that's going to be inequality number 2. So we will have 2 inequality at the end of the day. Okay. So let's write them. For flour, obviously I have to go back to what they're telling me about how much flour is needed per cake, right? So it's all in grams. So I need 150 grams for every cake A, right? And I need 75 grams for every cake B that I make. And whatever that combination is, it has to be, what would you say, less than or greater than? Less than, right? This combo, the flour, right? You're making a bunch of cakes. Whatever combo you make, it has to be less than or equal to your maximum. What would you put here? This goes back to minutes and hours, by the way. 50,000. Yeah, because 50 kilograms times 1 kilogram has 1,000 grams. Oh, didn't we do this already? Oh, yeah. That's interesting, right? So it's 50,000 grams because you have to have the same units. That makes sense, right? I'm just throwing that in there. So this is IQ1. So this is my first inequality. And then I'm going to have a second one. How would you state that? It says you have to produce at least 500 cakes. Richard, you want to give it a go? No? Okay. X plus Y? Yeah. Gabriel's saying X plus Y is greater than or equal to 500. That's right. Yeah. Does that make sense? Because what does X represent? The number of cakes A, right? And Y represents the number of cakes of the B type, right? So if you add it up, whatever combination, that has to be greater than or equal to 500. So I will just say this. Max of 50 kilos of flour and at least 500 cakes. That's basically what we're saying. We're translating the sentence into an inequality, and then we can narrow down and see, hey, well, how many can I produce of each? What's even possible to make given these restrictions? So this is the implicit restriction. This is the restriction you got out of the text, right? So now we can go ahead and graph this. You're going to love the second type. This type is going to be your favorite, and I'll show you in a bit why. Okay, so let's go ahead and now we graph. Now it's back to what you did earlier. Okay, so the first one right here, 150x plus 75y is less than or equal to 50,000. I'm going to find my x-intercept and my y-intercept. Right. So we have 150x is equal to 50,000 Divide both sides by 150. And that is 333.33. So that's what it is. So don't let that scare you, right? That's just what it's supposed to be. And the other one is 75y is equal to 50,000. Divide everything by 75. Y is equal to 666.67, which is 0, comma, right? So you have both intercepts there. And now you will see that the numbers are, as you can tell, they're getting bigger, okay? So we're gonna have to adjust our scale accordingly. Let's rewrite that thing. 75y is less than or equal to, what happens to the 150 when it comes over? It goes negative. Whatever sign it has, it goes opposite, right? So negative in this case, plus 50,000. And then we divide everything by 75, and 75 is not negative, so we don't have to worry about it. Y is less than or equal to negative 2x. And here I will show you a little trick. I would say do this. Keep it as a fraction. And well, you can reduce it, of course, but if you divide that, you get a decimal like this, and when you go ahead and graph that, your answer will be slightly off from what I will have. If you keep that as a fraction, you're using all decimals, okay? If you want to use 4 decimals, then you'll be fine, but nonetheless, there it is. So this is going to be a solid line. True is below. We will shade above. Why are we doing reverse shading? Because when we do a system, it's so much easier to find a solution. That's that. The second one, this one you're going to love. And I will do this once for you. Because look, if you do the x-intercept and the y-intercept, it's just 500, 0, 0, 500, right? So x is equal to 500. So it's 500, 0. And y is equal to 500 here. So it's 0, 500. You just have to make sure you write it in the correct order, I guess. So you won't even have to do a whole lot of math there. And that's y is greater than or equal to, the x comes over negative, right? Plus 500. That one is solid. True is above. We shade below. Maybe I will circle these, because those are the ones we want to enter into our calculator. So let's go ahead and enter those into our calculator before we even start graphing, just to make sure that we fit that on our graph. So go ahead, clear y is equal to, I'm going to clear whatever I have, negative 2x plus, I'm going to put that in brackets, 50,000 divided by 75. And the next one is just negative x plus 500. I'm going to go ahead and graph those. And you're going to have a problem, right? What should our window be set to? Our largest x value is what? 500, right? And our largest y value is 667. So let's do something with our window. Go window, X max, I'm going to go to 750 or something like that. Okay. And Y max, I'm going to go 600. Something that is a little bit bigger than what the max is. And then hit graph. What went wrong there? Why is the... Oh, sorry, I meant... Oops, 750 for the Y max. So make them both 750, that will work. Yeah, I was off. I meant to say the Y value, the biggest is 667. Now hit graph, problem solved, right? So if you make sure that your scale goes to 750 and 750 or something like that, you'll be fine, right? Your corner point will be on the screen. So that's all you want to make sure of, that you can see them. So now we can go ahead and graph this. Unfortunately, I have to go to the other, to my second page here. What quadrant are we going to be in? Why did I not care? Because it's a word problem, right? It's a word problem, right? The inequalities didn't just come out of nowhere. They came out of that word problem. So watch how I do this. I just draw my first quadrant and I try to make it work. So I will go up by 100. 1, 2, 3, 4, 5, 6, 7. That is good enough. So I'll just label every second like that. And I will do the same going up. 1, 2, 3, 4, 5, 6, 7, 8. I can fit 800. That is plenty. So a reasonable scale. This one is number of cakes of the A type. And this one is the number of cakes of the B type. So you need to adjust your scale. So now we're going to plot this. So we can do, the first one is 333 is right about there for me. And 667 would be right about there. They're all solid, right? So that's the case 99% of the time. When you do a word problem, you're going to have solid lines. 99.9% of the time. I might test you, like here and there, I might throw a curveball on there. The next one is 500, 0. Sorry, 0, 500 is this one, and then 500, 0 is out here. So the lines cross. If they cross, so some students like to just make an arrow going out and then label it, and that's fine with me. X plus y is greater than or equal to 500. And then this one is 150x plus 75y is less than or equal to 50,000. Right? So you have them both labeled. So where do I shade the first equation? What did I determine? Shade where? Above, right? I'm just gonna double check because I'm asking you to tell me what. So shading above, correct? Okay, so what you need to do is follow that whole line, and I would say before you commit, just lightly shade, right? If you're not 100% sure, but you follow that whole line, and following that line, right, all the way, so everything above that line is technically gone. So all of that is gone. Your shading, that's false for that first inequality. And the second one, what did we determine there? Below, okay. So I'm following the second one here. And first I'm just going to go light, right? And I follow that line and I shade below it. And it happens to have a bit of an overlap already, right? That's okay. So there you have it. So now if you're sure about that, you can go a little bit over it again and just make sure that your solution region sticks out. Question, Ben, or no? No. You just, okay. So then make sure you have your solution in there. There's this corner point right here. We're going to have to use our calculator to find. These two will just read it off. Okay. I'm just going to check, I did this off script, the A, B, C, D, like I did that off script. So I'm just going to make sure we defined, we did this, we did that. Graph is D. So this is answering D. E is asking state a possible solution. A possible solution. So you would just need to make sure you pick something inside here. So let's follow this. This is the 100 line. So 100 and what? 420, 100 and 425 maybe? Or if you want to stick along the y-axis, 0, 600, would that work? Yes. Yeah. So let's go 0, 600. So check. You have to check it for both. Right, so that's 75 times 60, 600, sorry. That's 45,000. Can barely see that, eh? Sorry. So this is good, and then you check x plus y is greater than or equal to 500, and obviously, right, it's going to work out for us because 600 is greater than. It only has to answer both, one of them, right? So that's check. So therefore, it is a solution. Baking only 600 type B cakes will work. It will create a profit and it will make sure you don't use too much flour, right? It does both things. That's what those two inequalities represent. And then F, POIs. I'm just going to read off. So one is 0, 500. I read that one. The other one is 0 point, right? I also read that one off my graph. And then that last one, I invite you to do this as well, is if you have your graph, right? You just go second, trace, 5. And basically you can close your eyes because there's only 2 lines, right? Enter, enter, enter. And so it's 166.67 and 333.33. And that is calculator. But you have a problem. get something else? Oh yeah, I don't know what that is. I honestly don't know what that there. Yeah, I don't know. A glitch. It's like video games, they have glitches, right? Okay. Middle of nowhere. It's a Google search away, just like you can now graph vertical lines. Isn't that awesome? Anyways, uh, here, hold on. There's a problem. What are we talking about? Cakes, right? Can you have 0.67? You can't sell, right? So discrete, discrete data round, right? So 0, 500 stays. This one will round 0. We'll just round it up like that. And then this one, we will go 167, 333. To be honest, if you round up or down, I won't make a big deal out of that, as long as you do a whole number. I would say round up or like round up accordingly. But I want both of them to be there, okay? Okay, 1 second here. Don't pack yet, don't pack. You want to write this down? There's one question on each page. Yeah, there's a lot of room. You can do all of the work right on here, right in your booklets, okay? I will post the answer, I will not post the answer key. And the reason is, do you want the answer key? Okay, I will post it. I was gonna go over it the next day anyways, but